So these are going to be our parent functions. All right, so f of x equal x squared. So x squared is a parent function. So x squared is a parent function. From that function, I can build other functions like x squared plus 7, x minus 2 squared minus 6, things like that. So I can build other quadratic functions. Just knowing the parent function, I can translate this graph to get other graphs. And then the other parent function you're going to have to deal with is the absolute value function. And then the other one is the square root function. So those are your three parent functions that you need to be able to graph. Now, these two right here involve 5 points that you have to translate. So you're going to use the same 5 points each time. 5 points for this one, 5 points for this one, and for this one we'll use 3. So the 5 points, and I asked you to look at the video, so hopefully you did, and you'll know what I'm talking about. But when I look at 5 points here for the parent function, if x is 0, what's 0 squared? 0. If x is 1, what's 1 squared? If x is negative 1, what's the negative 1 times itself? How's it 1? If x is 2, 4. If x is negative 2, I get 4. Okay? And so when I graph this parent function, I get 0, 0. I get 1, 1. Negative 1, 1. 2, 4. And negative 2, 4. And so I get this. Okay, so that's f of x equal x squared. So on that worksheet that you picked up, one of the things that it stated was that they want you to draw the parent function and the final function. So you're always going to draw the parent function. So if you look at that worksheet that you picked up, that's what it said. So there'll be two graphs on each of those grids, the parent function and the final function. Okay? So there's your parent function. These are the points. So you're gonna use those points. There are 5 points. Make sure you always denote those 5 points. I mean, not label them, but make sure you can see the dots there. Okay, so what's going to happen is this now. So now we're going to graph g of x, which equals x squared minus 3, let's say. So that's what I want to graph. So I want to graph g of x, which equals that. And so in the video, do you remember what that negative 3 said to do to the parent function? What does that negative 3 do? Nope, not at all. It's a vertical shift. So basically what's happening kind of makes sense because look, if I'm just going to do a couple, if I were to use, let's say 1. When x is 1, I'm going to cover this subtract 3. What's 1 squared? 1. So you see where I had 1, 1 here? But then I got to do what to this y coordinate? Subtract 3. So I end up with what? Negative 2. So I'm going from a y coordinate of, the x coordinate stays the same. I'm going from a y coordinate of 1 to a y coordinate of what? Negative 2. So that's a vertical shift. So that's on the outside. So the numbers on the outside is a vertical shift. And so when you graph this, I'm trying to use this transparency. Okay, so when I graph this, I'm going to go ahead and trace what we just drew. Okay, so now I'm going to graph g of x equals x squared minus 3. So basically that subtract 3 says I'm going to take this parent function, I'm going to shift it down 3 units. 1, 2, 3. So that's how it's supposed to look. So I took the parent function and I did what to it? Shifted down 3 units. So basically every point went down what? 3 units. This point went what? 3 units. This point went down 3 units. Okay? And so when you do this, so you're just going to take this point, go down 3 units. 1, 2, 3. Take this point, go where? 3 units down. 1, 2, 3. This, 1, 2, 3. 1, 2, 3. 1, 2, 3. And all you do is connect the dots with a parabola that looks like a parabola, you're done. All right, and it kind of makes sense. And if you have access to transparency, it does help. So let's just go down 3. 1, 2, 3, and you get this graph. Okay? All right, now remember what I just graphed here was g of x. This is g of x, which equals what? X squared minus 3. That's what it is. So that's what I just graphed. Okay? So this function here only involved how many transformations? Just one. All I had to do is take the parent function, move it down 3 units, and I'm done. Okay? All right, then real quick, what if I had this? So let's say this is number 1 here. Let's say number 2, you want to graph g of x, which equals x plus 2 squared. So now where's the 2 located? Outside or inside? Inside. If it's inside, it's what kind of shift? Horizontal. This is a horizontal shift. Now, here's the issue. Here's the issue. A vertical shift is easy to see. See the subtract 3? That subtract 3 says I go where? Down 3. The horizontal shift, students get mixed up on that. It's counterintuitive of what you think. So you see that plus 2? So they think that you go 2 units to the right. You actually don't. You remember when we did the vertex form, we said x minus h? You remember that? Well, that's the idea. So it's x minus a what? Negative 2. Remember that? So you're going to go 2 units which way? To the left. So horizontal shift, so that says I'm going to take x squared and shift horizontally. Horizontally, which way? How many units? So 2 units to the left. So it's counterintuitive of what you would think. But it's very similar to that x minus h. Since this is quadratic, you can use that x minus h as your guide. And so now you would graph this. Now, when graphing this, what is it you're going to graph first? The parent function. What is your parent function? And so in your mind,